Everyone, welcome back to our course on computer vision. I am Kaustav Tripathi, your instructor, and today we are going to talk about matching of contours. So, previously we have learned about how to find contours and draw them. Then we have talked about sorting of the contours. Now today we will talk about the most important and the most easy topic in the field of contours, matching of contours. So when we talk about matching of contours, that means we have one design and we want to compare that design, that shape in our all of those images, that whether that shape is present in those images or not. So this kind of basically helps us in finding in doing object detections and recognition, these kinds of shapes. This kind of matching of contours helps us a lot in finding, you know, objects, in detecting the objects. And it also helps us if you know, like some kind of an e-commerce website where you put a design of something, some cloth, like you say you want a cloth of this kind of a design, and you get immediately you get response related with that kind of clothes related with that kind of design. So all of these things happen means there is some kind of a role of computer vision of matching of the contours in there, that it matches, it takes up that design and it checks its design in its database where that design, in what images those design is present, and it displays the result. So that's what we are going to learn today. It's going to be a very interesting thing and a very easy thing, trust me. Okay, so let's get on to our Spider ID and see how we're going to do this. Okay, so this is our program on matching of contours from 35 lines with including the gap. So what we did here is we took two images over here. One is our template image in which there is a like a one shape present over there, and then there is a image which consists of lots of shapes. Then we are gonna check whether the our program can detect that template shape into all those shapes present in the another image, and those shapes will also be not similar, they will be different. Let me show you how they all looks like. This much first, and then I'm just gonna do I'm sure over here. Let me write I'm sure for that template also. Okay, wait, template image. Okay, so now if I run this much of the program over here in the below I'm sure part, I got two images. This is my original image where I have three shapes. I've used this image in my previous video also in sorting of the contours. It's the same image. And this is my template. It's a very big circle, and we are gonna see if it can detect a shape somewhat similar to this template over here in this. And I'm gonna show you how it detects it, how it finds out. All of the things I'm gonna explain you in this video. Okay, so these are our both images. I've also created this template with the same way I've created this image. If you don't know how, check out my previous video or the more previous videos where I've shown how to draw shapes. Okay, you can check both of those videos. I've explained both of those places, so go there and check it out how I did it. Okay, so these two shapes, these two images we have, I'm gonna just close it. Now I'm gonna talk about the program over here that I wrote. So we are using contours. So you know, in contours we basically use black and white images. That's why I have imported two libraries. I've read both the images over here, and I've converted both of those images in a grayscale, because uh, find contours method, or the finding of contours, accepts only a single scale images. That's why we have converted into a grayscale image. Then we have applied a little bit of a threshold over here so that they look almost all those color variations get somewhat similar in both of those images. That's why we applied a little bit of a threshold over here. Then we find the contour in our both of the images. You see here we have found the contours in both of those images, and we have filtered the, you know, that big contour on the window, complete window screen contour. Okay, we have removed those from both of those images. We have removed that window screen contour because it's gonna detect in both of the images and it will give it as a result, but we don't want it as a result. we want to detect work with the shapes. So for the template, I have used this because in template there are only two shapes present. One is a big window and second is that big circle. So to remove window, I've sorted it with the reverse true and use the index 1 because we are when we sorted the template image, it has sorted in a decreasing order because the reverse is true. And if you don't know this sorted method or the fine contours method, watch my previous video, just previous video, and there I've explained how this sorted method works, how this fine contour method works. So go take a help from those videos. I'm not gonna explain every concept in every video, okay? So basically I use the reverse is equal to true. That means it's gonna sort our contours in a decreasing order. So that means the biggest contour will come at index 0. That's why I chose index 1 as my at index 1 definitely there will be a circle contour. That's why I just selected the index 1 contour over here. And then I find the contours inside of my shapes images where I have 3 shapes present over there. And then there also I applied a filter that's starting from 1 to last. I don't want the index 0 over here also. Then what I did, now the main part comes. This much of the part is only here, that is detecting the matching the contours in the images. Okay, only this much part. So what I did over here is I just give some variable over here, s match is equal to 10. This is just one variable over here. Okay, you will get its significance later when you will understand the code over here. Then I use a loop for seeing sorted contours. Means C will go all those contours that are found in this shapes.jpg image. That C variable will go through them one by one, and it will give its cv2.match shapes. This is a method. cv2.match shapes method is a method to compare two contours, where I've given template contours, which is our template contour over here, and the C that is coming out from the sorted contours. Now in sorted contours we have 3 contours: circle, square, ellipse. Okay, so it came out with a C. At first whatever will come in the C variable, and we'll compare them together. Not two is the there are 3 methods actually to do this. Okay, they are like 3, or you say, mathematical formulas to do it. Okay, so you can try with any of the mathematical formula, 1, 2, 3, doesn't matter, they all works perfectly fine. They will always give you a good result. They are they are made by highly trained people. So doesn't matter whatever method you choose. I took 2, you can take 1. I can show you the result from all of those 3 methods. So it's just simply 1, 2, 3 methods. And this fourth parameter, this don't work with that. This is a work in development kind of a parameter. Okay, OpenCV is still working on this parameter. It does not have much of a significance up till now, so there's no point of it. Just give it 0.0. It's a float number, so give it 0.0 and just leave it. Okay, so what happens is when we use this, let me run the whole program to explain you up to this part. Okay, print match. I'm gonna run the program up to here only to show you what actually happens. Okay, I did a F9 and I got a output over here. Let me just adjust my screen over here. Okay, there's no point of it. Okay, so these 3 are outputs. One is 0.0279, another one is 1.2733, and then the third one is 0.0322. Okay, so these are some outputs are there. Now what basically these outputs means is our contour, our template got compared with all of those 3 shapes, and from which shape the more the closer, or the more likeliness will be present over there, the more the value will be inclined towards 0. Means the more similar that template will look to the shape of our shapes.jpg file, the more value will be near to 0. So the smallest value will signifies that this is the most closest similar looking contour present in that image. Okay, so most of the times the shape is not exactly in that image, but yeah, a similar version of it. So it matches with a similar version. If the value is exactly 0, that means that exact shape of length, breadth, height, exact everything is similar to over there, then that becomes exact 0. Otherwise it will always vary between 0 to 1 something. Okay, so these are the values over here. So that's why I have now that's why I've used here s match is equal to 10, because actually I want to find the lowest number over here, lowest match value over here, to compare, okay, to know which has the lowest match value, because that is the most similar contour present over there. Okay, let me run this whole program and show you what's happening over here. Okay, this was the circle I made over here, and you see here in the original image it is detecting the circle as a most similar contour. Now even it will somewhat find ellipse also as a similar, but more closest is this circle present over here. Okay, because you see the size of the circle over here is somewhat similar to the size of ellipse, only you need to stretch ellipse a little bit, it will look exactly like a circle. But here this circle over here is giving more closer reference to this template image over here. So that's what I did a little bit of a sorting technique over here. Okay, I just find the lowest one of all these three values, and I give s match is equal to 10. You can give it any value over here, you can give it 100 over, because I know no comparison will be any greater than 10. Even if the comparison is greater than 10, then I don't think that value is anywhere defines that the template is anywhere similar to the JPG image. Okay, because 10 is a very high number and we need a number that is real close to 0. So that's why I picked 10. You can, you want much more clarity, you can go with 100 or the biggest number that you can think of. Okay, it's like a random, just a number that I took, because I know that whatever the number will come, that will be below 10. So that's why I was comparing it over here. You can see I was doing whatever the match value comes from here with the cv2.matchShapes function. Whatever the match value arrives, I compare it if it is less than 10, because I need a value less than 10. So what I did, I take this c value inside of this cnt variable, which is my contour variable over here, which I use later on the draw contours section, okay, function, sorry, and I transfer that match value in the s match. So next time whatever the value will come, it will be compared to the previous value. Okay, so means first I got the value, okay, then next value will be compared with the previous value. If it is smaller, then again the next value will be compared to that smaller value. Okay, so that I can reach up to the smallest value over there present, and I can find its contour value, whatever the contour list it owns, and I draw that same contour over here. When I draw the contour, I got the original image drawn with that contour boundary over here. Okay, now if you want to do a little bit of experiment, okay, so this over here, now this was my file from which I draw that template image over there. You can work with a rectangle also, create a very big rectangle of some kind. Let me show you how this rectangle is gonna look like. Oh, wait a minute, let me run it. Okay, this now our template. Oh, wait a minute, my mouse is again glitching. Yeah, okay, wait a minute. Yeah, you see, this is how our image looks like. Okay, now right now I've created another template and it looks like this, a big piece of bar kind of thing. Okay, I'm gonna close it. Now I'm gonna get back to our this matching contour section, and I'm gonna run this program again. And you see our template is like this, and it is accepting it is most similar to this square, because it's got like 4 boundaries over here. It has also 4 boundaries, much more similarity than the square in comparison to circle or ellipse or any other shape. If there's any more shape present over there that has got more similarity than this square, then it will have taken it as a more similar one, and it would have drawn a contour over that. So that's how we find contours. You can apply any method over here, 1, 2 or 3. You can check with the 2 also. Let me show you. Again similar answer. You can check with the method 3 also, and the answer will be the same as expected. Okay, methods are there, all perfectly fine. Yeah, in very high standard somewhere they differ with each other according to their according to like circumstances that you need to experiment on with. Okay, so this is all in the matching of the contours. Just it's very similar, simple concept. Okay, just try it out. Great, when I learned this concept, I tried with the my downloaded lots of shirt images and compared a design of one shirt into all those images to find the better which has most similar images and to display those images. So you can try this kind of a project over this concept. Okay, it will really help you. Okay, so this is all in the matching of contours. See you in the next video.